Hey all, my name is Mel. I'm a data scientist and a BI consultant, and I'm here to talk to you a little bit about data shift and the implications that they have on our daily work as data scientists. And I'm gonna start with a story that actually happened to me. A client of mine in a project that I was involved in used their internal procurement using this form where the users could fill in this category and the name using a drop-down menu from a selected list and add some additional description. But what happened after a while was that this interesting data set happened where some of the records and some of the users actually used the drop-down menu and some did not. They just filled in this free text. And that's when we came in and the client said, well, can you handle this? Can you classify this free text records and match the catalog so that we can see who's doing what? And we said, okay, not a problem. Those are the same users, the same clients, the same customers. Everything is being done similarly. It shouldn't be a problem at all. So we did whatever a machine learning data scientist does. So we split our data, we cleaned it up, we used some imputation, made sure that everything seems right, and then we split the data set into a training and a validation set. Now remember, the training and the validation set that we used had actual labels, but the testing set did not. And we trained our models, and what do you know? The results were off the roof. They were amazing, and there was so happiness and fun going on. And we said, okay, let's give the first batch for manual evaluation for the domain experts. And then we weren't crying, and then we weren't laughing and partying that much because they said, listen, you got some of the records right, but the majority of them are just way off. Go back to the drawing board and try to understand what happened. And we had no idea because everything seemed very straightforward. But after a lot of time and money and effort spent, we actually realized that the reason those users were not using the drop-down menu is because they couldn't. Yes, they couldn't. Those items were not in the catalog because the product or the IT team just did not put them in on time. And actually what happened was that there was a divergence. Two populations occurred within the same data source, within the same company that worked separately, entirely separately. And that made our work harder. And that's in just what it means to have a data shift in your data. And the reason that this happens is because, well, machine learning magic, at least the supervised one, works because there's this assumption that the input has some sort of relationship with your target variable, the output. And whenever one of these factors change, modify, or break, well, that's when you get data shifts. And you've probably heard some form of or another of the term model shift or drift. And usually people mix them up, but they're caused by different factors, and the way to correct them is slightly different. So I want to deep dive a little bit further into this and see if we can figure out what to do when. So covariate shift is caused when there's a divergence in the input variables, in the independent variables. And the easier part to see is when the training distribution is different from the test, because then you will train a model in a training data set and you will look at the test result and they will be off and you will know that something's going on. But the trickier and the more important part is when the test and the train look similar, but they're very, very different from the real world, the entire population. Because then during research phase, everything will seem perfect, which what happened in our case. But when you go into the real world and the variance is so much bigger, your model will fail. And this is what happened to this poor fella. He tried to estimate people's ages by looking at face images, and his model worked really well. And this is what happened to this poor fella. So covariate shift is usually caused by two major issues. One is selection bias, because we are biased people. We know what we know, we have our prejudice inside, and our data actually represents that. So this is what happened to this poor fella. He tried to predict people's ages by looking at their faces, and his model worked really, really, really well in Europe, but it bombed in China because it didn't even think that there would be a difference in evaluation. And the second reason that's causing covariate shifts are undersampling. So try to guess what that is. Any guesses? Embryos, eggs? Those are retinal scans from mobile devices, and these researchers are trying to evaluate level 2 of diabetes type 2 in patients just by looking at the retinal scans. And they're using mobile devices. And in the US, the mobile device market is highly, highly skewed towards Apple devices, which means that if you're training a model with imbalanced classes, let's say that Xiaomi has a really low representation, then A, it could go away in the model and does not get enough representation, which means that your model will have problems predicting correct diabetes type on Xiaomi devices. And this is undersampling that's causing covariate shifts. And now let's say that you want to create this model that's going to predict the flavor of an ice cream. And the model is perfect. It always gets the right flavor. But what happens after a while, after 2 hours? Is the ice cream still an ice cream or is it not? Well, it's a puddle of goo. And basically that's what model drifts and concept shifts discuss. They discuss the fact that the distribution in the target variable and the independent variables does not change, but the relationship between them does. And now the model will not work. And that's usually caused by non-stationarity, because you see the models, they are stationary. Once you've created them and you've deployed them into production, they know what they know. The model will always say it's a chocolate flavored ice cream. But we live in a non-stationary world, and different processes affect the results and consequences. And if you think about it right now, we live in this huge, huge era of non-stationarity and instability, because due to COVID-19, everything has changed. Our mobility, our shopping habits, our psychology, everything is different. And most models will need to be retrained, or more data will need to be collected. And if we look at this plot, this actually represents number of flights going on in from 2019 up to now. And you can see that if you're trying to train your model on the past, there is no way that you will be able to predict this kind of behavior using a stationary model, which means that you will need to identify the shifts that's going on. And if you think about it, the number of routes a fleet has, an airline has, number of planes, the world population, that has not changed. The input into the model did not change, but COVID did, and it changed entirely the way the model will work and the relationship will work. So why am I telling you this? Is because you need to be aware of the different types of data shifts. They will happen everywhere. And if you think about this cycle as your research life cycle, then most of the time data scientists will spend about 1/4 of their time doing some cleanup and looking at the data and investigating it, and then they will jump into creating these complex models, complex features. And what will actually happen after a while is that they will get poor results, and they will spend a lot of money and energy and frustration trying to create even more complex models just by not spotting previous shifts in the data. So just trying to tell you this just so that you will not get over frustrated and go back and check it and look at your data further on. And let's say that you've actually managed to overcome this and put a model in production, well, then you still need to track it and make sure that the performance does not degrade over time due to non-stationarity. So be aware. And now that we know that we need to be aware, we'll need to see how to spot them. And the easiest way to spot shifts is just visualize your data. You can look and compare the different histograms and make sure the similarity of them. So this is a really simple Python snippet code that just compares the different bins, and you can see that actually the previous histogram, which looked slightly off, they're pretty much similar. And if you want to go into the source code, so you will see a bunch of QR codes that you can just scan and get more information. So the important thing to remember here is that no matter in which domain or which data type you're working with, most of them will have a library or a code that will compare the two populations. So you can look at cosine distance between your different embeddings and your word vectors, or if you want to look at numeric data or even image. So you can compare two populations and see if what you're trying to research and what you're trying to predict actually matches. So Google it, have a look, probably you will find something. And the population stability index is here to try and track your model in production or even during research phase. So what it basically does, again, it tries to compare the different shifts in the height and the beams of two groups, two time frames, whatever you're working on. And you can actually see that if you look at the number of flight plots, from January 2020, we could actually see a huge spike in the population stability index, which means that something is going on. There's a shift. The icebergs are melting. And there's a simple rule of thumb that says if you're below 0.1, then you're good to go. But if you're higher, then you need to start tracking your model and possibly even retrain it. So the data will never tell you the full story, though, the 360 of everything that you need to know about your domain and your business. And if you've tried to spot the shifts and you've used all the numerical methods and you still don't understand what's going on, consult someone, talk to a subject matter expert, an end user, a product person, and they will probably offer you either a new data set that you can look and analyze or some sort of business explanation that you can use. So you don't have to be a hero, you don't have to do it all by yourself, just speak to someone. And now that we know how to spot the shifts, we must correct the shifts. And the most obvious thing to do is, well, get more data. You have some form of bias or undersampling, get more data. What's the problem? But it's not always as simple as it sounds. And if more data is unavailable, then we will need to find new methods to reweigh the different undersampled classes or the bias data that we found in our data set. So there are a bunch of methods. You can read all about them, or if you want, you can just send me a text and I will try to find you some references. I like KMM because it tries to match the different distributions so that you can train them in a single model. So just try and reweigh the samples that you have. And if push comes to shove and you weren't able to do it, then you can always just rip this population to a separate population, a separate data set, a separate model, and just trying to train it as a segment of your population. And you can always combine the results later on in post-processing or in ensemble modeling. So you don't have to insist on a single model. You can always split it and then put it back in with some post-coding. So be aware, data shifts and the different types of them are everywhere, basically in every single project that you will be working on. So you need to be aware of them and not ignore this data as some outlier or something that you can't explain. So try to find them, and if you can't find them, consult someone, speak to a domain expert, and if you can't do it, just try to split it into a separate population, but remember to correct the shifts just to get better results and quicker results in production. And that's it from me. So thank you very much for listening in. This has been a really great experience, and enjoy the rest of the talks. Bye all.